Hello students, this is our class on MCS 502 Modeling and Simulation. This is the class on discrete and continuous system. Discrete system. If you see here in this slide, you have three different types of discrete events. First one is the thundering. Thundering, as you know, it comes very rare. It's not frequent event, and basically it's not continuous event. Rainfall in a day, if you see it rains, it rains not regularly, so it is not continuous process. Here you can see in the diagram from 11 a.m. to 1 p.m. there is raining. Again, there is a slight rain from 5 p.m. onwards. So raining is also a discrete event. Run in an over, if you consider the cricket match, then in an over, suppose the first ball which scored 4 runs, then second ball no run, third ball 2 runs, fourth ball 1 run, fifth ball 2 runs, sixth ball a big 6. So that is also not continuous. There is a breakup, because when there is 0, that means it is broken up the line. So it's not continuous run in an over. And that is very rare also. If you see the continuous event, here are 3 examples of continuous event. One is electrocardiograph, ECG, which is a continuous event until and unless the person is alive. Here you can see the graph is actually continuously moving from left to right. Day temperature, that is also continuous, because day temperature increases from a certain point. It increases, and in the midday time, that means from 12 p.m. to 3 p.m. during that time the temperature goes very high. And during that time, if suppose there is some raining or some sudden weather change, then temperature may fall. Here you can see there are some variations also in the graph. So this is a continuous event. Even the water level of a river, that is also a continuous event. Continuous. Suddenly water level never goes from top to bottom, bottom to top. So this kind of event is rare to see in natural. Run rate, if we consider the same cricket match, then run rate is a continuous event. You can see 2 graphs are there. Every time there is a run rate, that means run rate sometimes goes up, sometimes goes down. So run rate is also a continuous event. Some basic terminologies in this lecture, like system. In the earlier classes also we have discussed about system. A system is a collection of distinct objects which interact with each other. Model, a collection of pertinent information about a system, is called a model. State, for a given system, there are a number of variables that describe the system, is the state of the system at any given time. So these 3 terms are important for understanding the discrete model and the continuous model. Now let us see what is a discrete system. If we are talking about a system, then A discrete system is one in which the state variables change only at a discrete set of points in time. Here you can see discrete system is there where some inputs are given, which is discrete input, and output is also in a discrete vector, and it is giving the same type of output. Some properties of discrete system: time-based, and it is a time-based system where time is not continuous. Number two, absence of consistency. It's not consistent. Forecasting is difficult. When discrete system is there, forecasting is a bit difficult. And countable number of states. Discrete system changes from one state to another, but there is finite number of states. A computer is a finite state machine that may be viewed as a discrete system. So computer system is nothing but a discrete system. Now let us see what is a continuous system. Continuous system is a type of system in which state variables change continuously with respect to time. Here you can see xt, which is a function, and it is of the type continuous. The graph you can see, it's gradually increasing, gradually decreasing, which is the input of the continuous system. And in the output side, yt, there is also another continuous function, which is giving us this smooth graph. So continuous system is that one where input is continuous and output is also continuous. Some properties of continuous system, like continuous system is based on the continuous time. Continuous system is some extent consistent. Continuous system can be forecasted very easily if it is monotonically increasing or decreasing. But the forecasting will be difficult if fluctuation is there, if there is variations. Types of simulation models. While we were discussing all these discrete system, continuous system, discrete model, continuous model, because ultimately our target is to simulate. So in the simulation, there are basically two types of simulation models. One is continuous simulation model, which has basically these features based on mathematical equation. Continuous system is based on mathematical equations used for simulating continuous values for all points in time. For example, the amount of time a person spent in a queue. In any queue, you can see here in this animated picture, people are standing in the queue, and each and everybody is spending some time in the queue. So that is a continuous process. It's continuously going from one end to another end. So this is the real-time scenario of a queue. In the discrete simulation model, the specific values or specific point are used. It's not necessary. Suppose there is one array. We are not starting from 0 to the last. Discrete system may take a portion of the array. Suppose we require array indices from 5 to 10. So a of 5, suppose a is the array. So a of 5 to a of 10. That is our point of interest. So in discrete simulation model, the point of interest area will be focused and it will be used. Skipping or excluding the other parts of the array. So that is the meaning of the discrete simulation model. If you see the example of discrete simulation model, number of people in a waiting line, that is a discrete simulation model, is real life discrete simulation model. Because in the waiting line, there may be 2 people standing at a point of time. Just after that, there may be 10 people waiting in the queue. So it's a random event, it's a real life event, and the number of the people in the waiting queue is a discrete phenomena, discrete event, and it will not be fixed. It will not be continuous. From 2, it may be 10, and from 10, it may be 3. From 3, it may be 5. So any number can be. So that's why it's a discrete event. And this kind of simulation modeling is called discrete simulation model. Continuous simulation model, as I have told you, continuous simulation modeling is actually natural phenomena, natural events around our surroundings are based on that. But whenever you are going for designing some model, designing some program, designing some model for the for some scientific work, so that scientific model will definitely be in discrete system. As our computer system, it's a discrete system. It's not continuous. So that's why. So this part is very important for you people. And why computer is discrete? We'll talk that issue in the coming class. Why computer is a discrete machine or discrete computer, and how finite state machines and all those things are working. We'll discuss in the next class. So it is very much pertinent when we are talking about continuous modeling, discrete modeling. So the basic comparison must be known. So here we are having the comparison. If you see here, system being simulated in continuous system, specific mechanical unit with complex functioning. Yes, specific mechanical units will be there in the continuous system with complex functioning. Functioning will not be very much simple. Discrete event models, there will be multiple organs, multiple entities, multiple modules, but the working will be very, very much simple. So that is the basic difference between continuous and discrete. Definition of system state. In continuous, you can see distribution of energy within system. It is distributing some energy or functionalities within the system. And in case of discrete event modeling, categorization of current system properties. So very basic difference. Typical measures of system state: position, altitude, velocity. So these are deterministic. It can be calculated manually also. And in the discrete event modeling, you can see here Q size, incidence. So these are not very easily calculated. Q size, what will be the Q size? It's very uncertain. What will be the Q size of the waiting queue? It's very uncertain. There may be thousands, lakhs of people waiting in the queue. Incidence, that is also unpredictable. So that's why there are different approaches used for finding out the values, not exact, but relative values. Like now, queue size may be fixed such a way that the value is not fixed, it's a variable. Queue size can be 10, queue size can be 100, queue size can be 1000. So keeping that idea in mind, queue size will be kept as a variable. Then the next point is typical factor driving updates, where in continuous modeling, time is the main factor, typical factor, which is driving the whole system, time, based on time. And discrete event modeling is actually based on states. It's changing from one state to another, from another state to another. You might have seen binary counter. That is purely a discrete event model. Because binary counter starts from 0. Whenever there is some addition, it's going to the next state. Some additions, next state, next state, next state. Again, it comes back to the original position. That means 0. So binary counter is that one. And similar system is there in the fuel filling station. You might have seen. Every time whenever they are filling the petrol or diesel, that system is reset to 0 every time. Suppose one customer has taken 5 liters, one customer has taken 10 liters of petrol. No issue. Each and every time, the person is actually resetting the machine to 0. So 0 is 0 state of the filling station machine is a state. And suppose 5 liter, 0 plus 5 is another state, 0 plus 10 another state. So this is a discrete event modeling. So in real life scenario, many events, many models we come across. These are all discrete event models. Then the next point is capability of simulation. In continuous time model, analyze deterministic dynamic behavior of a mechanical unit. Deterministic, we have already discussed that. Deterministic, this term, that means factors affecting the continuous time model are deterministic in nature. Where in the discrete event modeling, mainly factors are based on stochastic nature, interaction between entities. That means, and mostly variables are not directly, we cannot calculate directly. These are all dependent variables. That means in the next step, what will be the value of the state? Nobody can predict it. If we take the example of this filling station machine, a customer may take 2 liters. Suddenly his mind can be changed to 3 liters. He can say, no, not 2 liters. Give me 3 liters. So plus 1. So before starting the system, the person in the filling station cannot say it will be stick to 2 liters only. 2 can be 3 liters. So it cannot be determined before starting the filling operation. There are some common uses of continuous time model, like design and analysis of unit. These are real-time planning. And in the discrete event modeling side, you can see analysis and planning of operations with multiple entities. So these are the basic difference between continuous and discrete modeling. Here, one example, simulation example is there. Very simple simulation example. but you have to do using either MATLAB or maybe C programming or Java, whichever is compatible. Here you can see, take sugar in a container. Yes, to sugar container, we have a sugar container. Take water in another container. Yes, that is also taken. Mix sugar with water. You can mix gradually. You pour some sugar into the water and stir it with a spoon. It will be mixing. So two observations are there, two cases are there. Observe the sweetness quality increase with the increase of sugar to the solution, where solution quantity will have negligible increase. Suppose you have mixed water and sugar and you have got this sugar solution. Now, if we are adding more sugars into the solution, there will be negligible change in the quantity of the solution. But yes, sweetness will be increased. So that is the case number one. Case number two, observe the water quantity increase, the increase of water to the solution. When you will add, in the case number two, you can see, when you are adding more water into the solution, definitely the water level will be increased, but sweetness will be decreased. So that is a simple simulation example. You have to simulate this event graphically, either in Java or in C programming or in MATLAB programming, whichever is comfortable. So this is one assignment to you people. So this is a simple simulation modeling. That means in one side, sugar level will increase, sweetness will also increase. In another side, water level will be increased, sweetness will be decreased. And when you will increase the water level, the level of the solution will also be increased. So sugar quantity, water quantity, two inputs are there. And two outputs, one is the solution level, that is the output, and another is the sweetness. So two inputs, two outputs. Now you can understand the actual meaning of this simulation. You have to do some programming to show this simulation. So that is the end of this class. Thank you for viewing this video lecture.